Okay, this is the P4 paper from June 2024. It's question number 8, and this is a binomial expansion question, but it's also a proof by contradiction. So two different parts to this one. Let's have a look at 8 part A. It says fx is equal to that function there, where x is between 0 and 8 over 3. That might come important later on. Show that the binomial expansion up to and including the term x cubed. So yeah, we should absolutely be able to do that. So we've got A, fx is equal to 8 minus 3x all to the power of 4 over 3. So I hope you've done lots of these as practice. We know that we can't do it like that. We need to take that 8 out. Okay, we want 1 minus, in this case, 3x all over 8 if I've taken the 8 out. And just importantly, I haven't taken 8 out, have I? I've taken 8 to the 4 over 3 out. That shouldn't catch you out. You should have lots of practice of this. 8 to the 4 over 3 is 16, apparently. And then I've got 1 minus 3x over 8, all to the power of 4 over 3. So now I'm going to use my binomial expansion for 1 plus x to the n, which is 1, nx, n minus 1, x squared, over 2 factorial. That pattern carries on. I think we want it to the next term, so I might as well do it. So n minus 1 again, n minus 2, and this time x cubed, and over 3 factorial. So if we do that with functions we've got, remember I'm going to need to multiply this by 16 at the end, but to start off it's 1 plus n x, and x is, x is minus 3x over 8, plus n minus 1, so that's 4 over 3, and then 1 over 3. We've got our x squared, all over 2 factorial, and then finally, again, 4 over 3, 1 over 3, taking 1 off that again is minus 2 over 3. If you've practiced these, shouldn't be too much of a hardship for you to go through and get all these terms done correctly and accurately, and then just multiply everything out. That first term, 4 over 3 times minus 3x over 8, is going to give me minus x over 2. The next one is going to give me plus x squared over 32, so we're just putting our values in each time, and then the last one plus x cubed over 384, and then our fx that we actually want is 16 lots of that. Use my iPad just to save myself a bit of time here. So it's 16 lots of that, which actually then works out to be 16 minus 8x plus x squared over 2 and plus x cubed over 24. So that's part A done. Show it's in that format, so I've worked out what A is and I've worked out what B is. And second part, use proof by contradiction to prove that the curve with this equation doesn't intersect with the curve with this equation, which obviously we've got our answers to that part now. And importantly, between 0 and 8 over 3. Okay, so what I'm going to do, let's just talk about proof by contradiction. If it's a proof by contradiction, I'm going to assume something, and I actually assume the opposites of what I'm trying to prove. So I may as well do this now. I'm going to prove that that does intersect with that. So let's say that first of all. So I make an assumption. So assume that the line y equals 8 plus 8x minus 15x squared over 2 does intersect with what I had as my answer, which is y equals 16 minus 8x plus x squared over 2 plus x cubed over 24. Now let's just talk you through what we're going to do. So if we're doing a proof by contradiction, I make an assumption that I know isn't right, that's not right. I will now do some maths, explain what some maths means in a second, but you go through mathematical processes, and at some stage through going through this process, I am going to end up with something that doesn't work, a contradiction of some sort. As soon as I get that, I get something that's wrong, what I can then say is, okay, so my assumption is wrong, which means that the original thing that we were trying to prove has to be correct. So that'll make more sense now when I actually go through and do this one. But I've made my assumption. So if I've got the assumption, then that means that, that means that 8 plus 8x minus 15x squared over 2 is now going to equal to 16 minus 8x plus x squared over 2 plus x cubed over 24. So as I'm going through doing this, I'm hoping that I'm going to come across something that doesn't work. You might get a quadratic that doesn't solve. That doesn't work with this one, but that's one of the possibilities of what we could have. But just go through, just do exactly what you would do. So with this one here, what I'd do is I'd just tidy this up. So I'd take x cubed over 24 plus 8x squared minus 16x plus 8 is equal to 0. So I've just taken everything over to that side there and just made my equation equal to 0. So here then, what I'm looking for, and this comes through experience, is quite often I'm looking for perfect squares. So some of my students would say to me when I get to this stage, how did you know to do this? So you say, well, it just comes through experience of doing these, because it's quite a clever little thing here. That function there, I'm going to take 8 out as a factor. And if I take 8 as a factor, I get x squared minus 2x plus 1. And then this bit here, no excuses. You've just got to get good at doing these. That is x minus 1 all squared. You should know x minus 1 all squared, x plus 1 all squared. Anything that's a perfect square, well, let's write that down then as my next bit, and then I'll explain what we're doing. Plus 8 x minus 1 all squared is equal to 0. Well, this is one of our classic situations to try and get something as a perfect square, because if something's a perfect square, what we can say, for example, is I know what the lowest value of this can be now. This has got to be, the lowest value can be a 0, isn't it? If it's something squared is always greater than or equal to 0. So in this particular case, what we've then got to do is to also remember, I did say this at the start, that we've got x is between 8 over 3 and 0. And if x is between 8 over 3 and 0, then what we're going to find is this one here is greater than 0, apart from x equals 1. Okay, so unless x equals 1, 8x minus 1 squared is greater than 0, unless x is equal to 1. And if x is equal to 1, then that bit would be equal to, so x cubed over 24 would then be greater than 0. So because of that, what we can say is that this thing here, this total here now, this part actually has to be greater than 0. That's greater than 0, that's greater than 0, so that can't be equal to 0. Okay, the only time we wouldn't get that would be, obviously, x could be equal to 0 there, but that's not in my range, or x equals 1, but when x is equal to 1, then this bit isn't 0. So what we get here then is, because of that, therefore, x cubed over 24 plus 8x minus 1 all squared has to be greater than 0, which means there's a contradiction. Just have a look at that. Just spend a little bit of time looking at that and look at other questions of this sort of type, because that's not the first time I've done this sort of process here. So because of that, that has to be greater than 0. Therefore, there is a contradiction. There's my problem. There's my thing that doesn't work. I wanted it to be equal to 0, and it isn't. It's greater than 0. Therefore, my assumption is false, and I always finish every one of my proof by is false. I finish off every one of my proof by contradiction with these last two statements. My assumption is false, therefore, whatever we were trying to prove originally is true. So therefore, in this case, the two lines do not meet. Okay, I know you guys don't particularly like any of the proof questions, but there's just another one to add to your armoury. 4 marks for that last part. First part should have been okay. So, yeah, just keep practicing those. Hopefully, that all makes sense.